Hello Eng1060. In this video, I will cover how to create and use user-defined functions. Just like built-in MATLAB functions, user-defined functions have one or more inputs, one or more outputs, and that they're case sensitive. Different to built-in MATLAB functions, user-defined functions can only be called from current directories. So how do we create a function? Well, firstly, we can start a new M file or a script file. We can declare it as a function with a function header. The function header being the word function, then listing your outputs, equals, the function name, and then in parentheses having your inputs. So as an example, here is my function file. So here I have the word function, which is the same up here. Then I have my outputs, which is var a. Then I have my function name, which in this case is var b. And then I have my inputs, which is var c. This is known as the function header declaration. So consider the example that I mentioned in the previous video, where we were calculating the product of sine, cos, and tan for a particular input. Here, how can we better program this code? So we have x is equal to 5, y1 is equal to the product of sine of x, cos of x, tan of x, or sine of x squared, cos of x squared, tan of x squared, so forth. Mathematically, we can simplify this by writing y1 is equal to SCT of x, where SCT is just simply sine of x times cos of x times tan of x. Continuing on, we have SCT of x squared plus SCT of x cubed. Similarly, we can say Z1 is equal to SCT of x5 plus SCT x4 plus SCT of x cubed. And W1 is therefore Y1 plus Z1. This makes it much easier for us to write mathematically, and we can achieve the same thing by writing a function for it in MATLAB. So we need to create a function to compute the product of sine x times cos x times tan x. Firstly, we need to identify the inputs and the outputs of the problem. Again, the problem is shown on the left. We have x as our input, and it doesn't matter if it's just x or x squared or x cubed. We see that there is only a single input, that being x for the first line, x squared for the second line, and x cubed for the third line. So we can create a function by putting a function declaration or the function header at the top of the M file. If you recall, we have the word function first, then our output equals to our function name, which I've called SCT, and then next in parentheses I have the input. Now the primary aim of a function is always to calculate what the output is. Since our output variable is conveniently called output, we can define the output variable in the function file itself. So output in this case is equal to sine of our input times cos of input times tan of input. And this is basically it. This is our SCT function file. So now that we've written our function file, how do we use it? Recall we have the problem here without function files. This here is our function file. And to call it, we would simply use it as we would any other function. For example, sine of x. So this is a separate M file. And here I've defined what x is. So x is equal to 5. y2 is equal to SCT of x plus SCT x squared plus SCT x cubed. And similarly, the equation for z2. And at the bottom, I've added them together. So you can see the difference in the length of code between the left-hand side, where we're not using user-defined functions, and the right-hand side, where we have a function and an M file that calls that function. So just to be clear, our SCT of x is actually equivalent to this line here on the left. SCT of x squared is equivalent to this line. SCT cubed is equal to this line. And so forth for these z commands. Functions should be called by separate M files. So here on the right, we have the function file. And on the left, I have a separate M file. Do not run functions. This means we do not hit the run button on a function file. Instead, you run the M file which calls the function. Ensure that the current directory contains the function that is being called. Otherwise, it won't know where to look for your function. And just like built-in functions, all input arguments must be specified when calling a function. So for example, if you had a function which required 2 or 3 inputs, then you must specify all 2 or 3 inputs for the function to work. Function documentation is just as important as regular commenting in your M files. So you should include the following information after the function declaration. The function declaration without the word function. So here we have the function declaration. The next line is the exact copy except for the word function. So this is basically our syntax. We then have our name, ID, date, and description of what the function does in the following lines. This is then followed by a description of the input and output arguments. So input argument is just a number in radians. And my output is an output in radians. It is important to include the previous information in your function files because this is the information that is displayed when you use it through the help function. So if I was to type in help SCT, we will see that the comments following the function declaration will be displayed to our screen. So we have the syntax, the news information, the description, input arguments, and output arguments. This will allow one of your team members or someone who's using your code to be able to understand what your code is doing and how they can use the code. Remember, when writing functions, you are not always the only person to use this function. You may have to share it with others. So function documentation is crucial. Just like variables, function names should be self-documenting as well. So naming the sine Taylor function as cos Taylor would be a very bad idea. Make sure to use the same name for your function as your M file when you're saving. So the sine Taylor function must be saved as sine Taylor.m. Or in our previous example, our sct function would be saved as sct.m. Avoid using function names that collide with built-in MATLAB functions. So for example, MATLAB already has its inbuilt functions for sine, square root, plot, tan, etc. So use a prefix of my to avoid collisions. So my sine, my square root, etc. Remember that function files are black boxes. So therefore in function files, you should not display any text or information. Do not plot. Do not ask a user for an input. Do not use the clear all, close all CLC commands, as this would clear all of your variables as it gets to your function file, therefore making your function useless. Do not overwrite existing MATLAB functions. Do, however, suppress everything, and do document your code appropriately. As a summary, we looked at the function header declaration, which was function outputs is equal to function name, and then in parentheses inputs. How to create function files, and how to use function files. Lastly, we looked at documenting and naming function files. So as a last thought to this video, why can't you click run on a function file? Why must you instead use a separate M file to run the function file?